Hello you all, my dear. I am Rakesh Chaubey from Sunbeam Sun City. Jai Hind you all, my dear. My dear, today the topic is dimensions of physical quantities. If you remember, in the last video I have told you about the dimensions of a derived physical quantity area, second derived physical quantity volume, the third derived physical quantity was density, the fourth derived physical quantity was velocity, the fifth was acceleration, and the sixth was momentum. I hope, my dear, I have completed the 6 derived physical quantity dimensions very well. My dear, let us today again start with the dimensions of acceleration, momentum in this video again. I have told you all that we are supposed to do top 10 dimensions very well. You should learn by heart. Initially, I am giving you the method of how to derive this top 10 dimensions. But afterward, my dear, you will learn these 10 dimensions and you will apply these dimensions to the other physical quantity. I will show you this all in my videos today. So now let's start once again with the dimensions of accelerations. Now, my dear, if you remember, I'll continue here. I have written continue, CONTD. So let's start with the dimension of the quantity. That is, I am writing this as the fifth quantity, acceleration. Acceleration. Now, my dear, you all know that this is denoted by A, and any acceleration is the formula. The formula is, derived formula is velocity upon time. That is rate of change of velocity or velocity upon time, my dear. Now, if it is velocity upon time, I told you that acceleration is the derived quantity, right? But on the right side, the formula mein it is velocity V, which is derived quantity, and time t is a fundamental quantity. What I told you in my earlier video, that you break the derived quantity, that is here the derived quantity acceleration. I will break this derived quantity, right, till I will get the fundamental quantity on the right side. So now here the velocity is the derived quantity and time is the fundamental. I will break the velocity in terms of distance upon time. Distance upon time upon time. So this will become distance upon time square, and distance can be written for me as L. I hope it is clear. So this will become L by T square. L by T into T is T square. So now, my dear, looking to this, I can write its dimension with the opening box bracket and the closing box bracket. Here L is having 1 power, so here L power 1. There is no mass, so here m power 0. And T is in denominator. I have written in small letter, no issues, because while writing dimension I will write in capital. But right now in formula, I can write small also and capital also, no issues. So this is T square. When it will be written in dimension, this will be T power minus 2. Here it will be. So this is the dimensions for acceleration, and the answer is L1 m0 t minus 2. Now what is its derived unit? Derived unit of acceleration. My dear, derived unit, you can see the final answer is length upon time square. Length upon time square. Length has a unit meter and time square as a unit per, and there it is t square. So here I can write second square, meter per second square. So this is the unit, derived unit for acceleration, because here the numerator it is meter and denominator it is t square, so it is meter per second square. What is its so I write this as derived unit, meter per square second. And symbol for that will be meter per second square, this way. So my dear, this is the method, but what I wanted to tell you that you will learn the dimension of acceleration directly, that it is L1 m0 t minus 2. But well, if you forgot that how we got this, then what you will do, you will write the formula, it is velocity upon time. Velocity can be written as length upon time, whole upon time, because velocity ka definition is distance upon time. So this is distance upon time, whole upon time. That is distance, that is L, and T get multiplied, become T square. So what will be the dimension? L1, no mass, so M0 and T power minus 2. Here one more thing, How I got the unit of acceleration, derived unit? Sir, derived unit can be derived from this formula itself. What is the formula? Here, or you can see here also, length is L power 1, so there is 1 meter and no mass, so kilogram power 0, and here T power minus 2 can be written as meter. L power 1 can be written as meter or this meter, and S power 2 can be written as S power minus 2. So this can also be the answer. So looking to dimension, we can write the unit also, my dear. See, so nice. L ka power 1, so here it is meter, and T ka power minus 2, so here it is S power minus 2. So meter second power minus 2, which can be written as meter per second square. Okay. Now my dear, the next dimension which I supposed to give you is about momentum. Momentum. Now momentum is denoted by small p, and the formula for momentum is mass into velocity. Mass into velocity. Again my dear, mass is a fundamental quantity, it is remain the same, but velocity can be written as length upon time. I hope it is clear. Right? Velocity is written as length upon time, and mass is m. Is m only. So what I did, I break the momentum in fundamental quantity, but earlier the formula says that it is mass into velocity, where mass is fundamental, but velocity is not fundamental. It was derived. So what I did, I bring the velocity, I break the velocity, I derive the velocity in fundamental. How I break it? Sir, velocity is defined as distance upon time. So distance can be written as length and time can be written as t. So on the right side now, mass is fundamental, length is fundamental, time is fundamental. And on the left hand side, my dear, momentum is a derived quantity. So what I did, I break the momentum, that is derived quantity, in terms of fundamental. Now, what is the dimension here? What is the dimension here? L. So this is L power 1. Mass is having 1, so m power 1, and t is in denominator, it will be minus 1. So what is its derived unit, my dear? Or what is the symbol of the unit? You can see derived unit. Here m power 1, my dear, whenever we write the unit, we first write the unit for mass, and this is the reason why in dimension the people can write the dimension in terms of length, mass, time, or they can write the dimension in terms of mass, length, time. Mass, length, time लिखने से फायदा क्या होता है कि they can write the unit of mass first. Generally we write the unit of mass first. Whenever you will see any physical unit, you will see kilogram first, right? And one more thing, here it is power पे 1 है. I told you this can be written as L m t minus 1 also, because I told you if there is a power 1 plus 1, no need of writing that power, it can be written as this also. So here I am writing or. Now looking to the unit, what will be the unit? Now m having power 1, so it will be kilogram, L power 1, so it will be meter, and t power minus 1 in denominator can be written as S power 1 minus 1, that is kilogram. Here L के लिए meter and t power minus 1 as second power minus 1, or I can write this as kilogram meter per second. So this is the derived unit for momentum. Now my dear, the next quantity is the force, denoted by F. You all know the formula is mass into acceleration. Mass into acceleration is the formula of force. Now my dear, here mass I will write down as it is mass, and acceleration is a derived quantity. Now acceleration can be written as velocity upon time. I break the acceleration in terms of velocity upon time. But now my dear, mass is fundamental, time is fundamental, but velocity is derived quantity. So I will break velocity also. This will be mass, and velocity is broken as length upon time, whole upon this is time. So now what will be the answer? Mass into length upon time square. Mass, length upon time square. मतलब acceleration का formula होगा ultimately length upon time square also. You can see here. So acceleration first I have break into velocity upon time. आराम से देखो, right? Then velocity is broken into length upon time, whole upon time. That is already time was there in denominator. Once again, so force is mass into acceleration. Okay. Now mass is as it is mass because it is fundamental. So I am not touching it. But acceleration is derived quantity. I have written is velocity upon time. Okay. Now in second step, mass and time is fundamental. I have written mass and time as it is. Now velocity is not fundamental, it was derived. I break the velocity is L by T because velocity is distance upon time. Now I got the answer mass length and this T multiply become T square. So what is ultimately I wanted to say, acceleration का एक और method है and direct answer that L by T square. You can see here also the acceleration का direct answer is L by T square because velocity upon time is further broken into L by T square. है ना? यहाँ पे भी देख सकते हो velocity is distance upon time, whole upon time. Distance can be written as L upon T and that can be written as L by T square. तो कभी कभी student are using their logic. What they are saying, sir, mass is m, so they have written m, and then they will say directly, sir, acceleration is length upon time square. Acceleration का direct answer they remember length upon time square because they don't want to go in velocity upon time. Then velocity is further broken into length upon time. But ये कब करते हैं when you will have a more maturity. जब बहुत अच्छे से आने लगेगा तो you can directly say, sir, acceleration is length upon time square instead of saying velocity upon time. Because writing velocity upon time, again you need to break the velocity in L by T. So now my dear, what is the dimension for force? So dimension for force will be, here while writing the dimension of force, dimension of F. So my dear, when we write the dimension for quantity, we write with the box bracket. Now any physics teacher will read this dimension of force. Am I clear? So dimension of force will be how much? Here you can see mass ka power 1, L ka power 1 and T power 2 in denominator. So this will be L power 1, M power 1 and T is in denominator went up become T power minus 2. I hope it is clear. L ka power 1, M ke power mein 1 and denominator mein it is T square, so it will go up become T power minus 2. What is its unit? So derived unit of force. Now my dear, you can see first unit here L1 M1 T minus 2 can be written as, this will be can be written as M1 matlab kilogram, right? Power 1 है, so no need of writing power 1 at kilogram pe. Now L power 1, here it is meter, again it is power 1 and T power minus 2 can be written as second power minus 2 or this can be written as kilogram meter per second square. Or one fabulous unit you all know, Newton. So complete name of scientist is written with the small letter, all the letters should be small and the symbol will be written by capital letter. So these are the units for the force. It can be written as kilogram meter second power minus 2, kg m s power minus 2 or kg meter per second square, because this s power minus 2 can be written as meter per second square or you can say Newton. Similarly, my dear, the eighth quantity which I am writing, interested to write, is about after force is work, denoted by W. Now work ka dimension is, my dear, force into displacement. I will write here force multiply by displacement. Now my dear, force is F and displacement is say S. But I told you for dimension the displacement is also distance. The displacement, the distance, the radius, everything is taken as length. Am I clear? मैं पहले ही बता चुका. So here the formula is force into displacement. So now work is equal to F into S. Now F is broken into M into A into S, right? S. Now here this will be broken into M into A का क्या आंसर हो जाएगा? L by t square. Acceleration can be written as L by t square here. Okay, and S is displacement. Your distance or displacement is length. So S is your displacement, and this displacement is denoted by L. Okay, so now what will be the dimension, my dear? Here this will be n, right? L and L, here it is L power 1, here also L power 1, become L power 2 divided by t square. So what is the dimension of work? So dimension of work, here I will write, dimension of work is equal to ml square upon t square. So this can be written as L2 m1, because m के पावर में 1 है, and t power minus 2. L2 m1 t minus 2, t power minus 2. So this is L2 m1 t minus 2, or you can write this way, L2 m t minus 2. The reason is that if it is power 1, no need to write power 1, so it is assumed that this is power 1. You can write this way also. And what is its unit? Derived unit of work? Derived unit of work, you can see, my dear, here m के power में 1, m for mass, that is kilogram power 1, meter, L power 2, that is meter square, and t power minus 2, s power minus 2. Or I can write this as kilogram meter square per second square, kilogram meter square per second square, or joule, Joule, all the letter small, symbol capital J. और my dear एक और यूनिट है, it is force into displacement. वीडियो बरोबर देखो, force into displacement. force का यूनिट is Newton and displacement का यूनिट meter. So it is Newton meter also. So there are 3 unit for work. Either it is kilogram meter square per second square, which can be written as kilogram meter square s power minus 2 also. दूसरा joule, Joule, complete letter all in small and symbol is capital. और तीसरा unit is on the basis of their definition formula, that is F into S. तो F का unit Newton होता है, S का unit meter होता है, so this is Newton meter. So my dear, this is the method of cracking it down. So बार बार याद रखो, velocity का fundamental terms क्या है? velocity जब fundamental में break होता है तो क्या होता है? length upon time. कैसे पता चला सर? velocity का definition है distance upon time या displacement upon time. Distance and displacement is denoted by L upon time. हो गया, fundamental में convert हो गया because length and time was fundamental. Second important is acceleration, जो जगह जगह पे use हो रहा है. सर एक्सीलरेशन डिराइव्ड क्वांटिटी है, जब मैंने उसको फॉर्मूला ब्रेक किया तो आंसर आया वेलोसिटी अपॉन टाइम. वेलोसिटी अपॉन टाइम फॉर्मूला में सर वेलोसिटी डिराइव्ड क्वांटिटी था, तो वापस से मैंने वेलोसिटी को ब्रेक किया. सो वेलोसिटी को मैं अभी भी बताया कि वेलोसिटी जब हम ब्रेक करते हैं तो डिस्टेंस अपॉन टाइम या डिस्प्लेसमेंट अपॉन टाइम आंसर आता है. तो फंडामेंटल में दैट कैन बी रिटन एज डिस्टेंस और डिस्प्लेसमेंट इज लेंथ अपॉन टाइम, सो डिवाइड बाय टाइम. सो दिस बिकम एल बाई टी, ये वेलोसिटी के लिए हो गया, होल अपॉन टी, तो ये हो गया L by t स्क्वायर. सो एक्सीलरेशन का फंडामेंटल टर्म है लेंथ अपॉन टाइम स्क्वायर, और वेलोसिटी का फंडामेंटल टर्म आता है लेंथ अपॉन टाइम. सो ये दो चीज बहुत इंपॉर्टेंट है बेटा. सो आई होप यू आर क्लियर विद दिस 8 डायमेंशंस. नाउ आई विल गो फॉर सम मोर डायमेंशंस विद दिस, बट फर्स्ट you write it down by doing pause in your videos, and then you will go for the another physical quantity dimensions.